Well, if you're anything like me and you're a lover of tools, you love online auctions. I saw this box of goodies in there and started seeing a lot of stuff that had some value, but the thing that really stuck out to me, do you see it? Yep, it's that Fluke multimeter. These things are pretty expensive. This particular model, I couldn't tell what it was. Obviously, didn't even know if it worked, but because it was a Fluke, I took a chance on it. I'm going to take this thing out. I'm going to show you how to test it, test the fuses, service it, clean it up. So let's get this thing opened up and see if I got a good deal or I bought a box of garbage. Let's go. You know, when I buy a new tool, one of the first things I do is go and look for the manual. And I started doing some research and looking for the Fluke 87 to try to figure out what I got. And I kept seeing this true RMS multimeter. Wasn't quite sure what that was about, but when I grabbed a look at what it would take to buy one of these today, it was 485 bucks. So that's a pretty good chunk of change for what you can get for meters out there today. You know, if you go and you do a search, I mean, you can find a Fluke meter for 148 bucks. So the question is what's so special about a true RMS meter? And especially what we have here. Here's a used one, 166 bucks. By today's standards, that'd be a pretty good deal, right? But if we take a look, and I did some search on that, and it started to make sense right away, it's just that this is for a much more accurate measurement, especially around VFDs, computer, electronics. I saw that they were heavily used in the heating and air conditioning world, but I know for me that I'm going to be moving into using a VFD on some of my lathes and mills and whatnot. So I started thinking, boy, this would be maybe a tool I'm absolutely gonna need. So it made the deal at the swap meet there, the flea market, even better. So pretty stinking cool about that. But if you're interested in this, I went on to Fluke's website. They had a great video and some information on there on how it actually measures it. It's pretty interesting here how it's taking to get this RMS. It's actually taking and calculating the direct current value of an AC waveform. So this is definitely not your average everyday multimeter. What a great find. Well, why don't we get into servicing this thing, checking it out, and can always learn more about it on your own. I'll put these links I found interesting below in the description. Well, the meter looks to be in really good condition. It's just really super dirty on the cover there. I'll show you in a second, but I don't have any power, and I got something loose and banging in there, so I'm pretty worried at this point, thinking that it's got a broken circuit board or was dropped or something. But let me speed this up. So you want to be careful when you take these apart. You really don't want to get in there with screwdrivers and pry and slip with the screwdriver and then hit the circuit board or hit the switches. And try not to have a lot of pressure that you're putting in there. No battery in here, so I am happy about that. But what you're going to see here is I am seeing some old evidence of battery corrosion, so I'm a little worried about that. For the condition this thing's in, I'm really surprised how greasy and dirty the cover is, but whoever had this definitely put it to some good work. We're going to get this thing cleaned up and looking like new. Well, I figured I'd test it first before I went through the work of cleaning it up, because still don't even know if the thing works. So first thing we're going to do is we're going to check the 2 amp fuses. So let's take another meter, zero it out there, and then go ahead and test across each of the amp fuses. So you have one for milliamps and then one that goes up to the 10 amp. And both of those are good, which is great because those can be pretty expensive. Did you think your eyes were playing tricks on you? Did you see that in the meter? Did you see where it says ouch? It really does. Check this out. Nope, your eyes weren't deceiving you. Look at that. Ouch. So I have pulled out one of the leads. I just threw some alligator clips on there to hold the leads together to show you that when you have continuity, you're searching for a spec, it'll give you that. But if you had a break or an open, for example, okay, you would actually have the meter read ouch. I think some engineers get to have too much fun sometimes, but this is really cool. This is a 75th anniversary SnapOn meter. It's the MT586 ANV Multimate Limited Edition. Zoom in there. 706 out of 7,500, okay? And I purchased this in 1996, I think it was, working at a Honda Suzuki dealer back in Sioux City, Iowa, and this thing works flawless to this day. Now, I was kind of curious about that. I pulled it out of the case, the Snap-on version. It said it was a Blue Point product. Kind of zoom in there for you. And manufactured for Snap-on, and then it says made in Korea. I really expected I was probably going to come out here and see a Fluke reading on there, but I don't see anything. It's all branded with SnapOn. But hey, I got to tell you, this meter has absolutely just been awesome. It's been my go-to over the years for when I'm really testing stuff that really needed to be pretty specific. And I have a lot of meters. Here's a ESI one. This thing's great too. A lot of these meters read so similar. And then somewhere around here, I got even the little Harbor Freight ones I love when I'm just doing something really quick. But I thought you'd get a kick out of seeing it up close that your eyes did not deceive you. It actually says ouch when you don't have continuity. Pretty cool. Well, time to see if this thing works. Let's throw battery in this thing. Before I even put the screws in, I'm going to run it through a few rotations of the dial and see if the thing powers up. Well, did we spend 50 bucks and save 400, or did we spend 50 and waste our money? Let's see. I noticed the normal foam pad that kind of sets the battery up against the case for vibration and not allowing it just bang around was deteriorated or missing. So I'm going to show you a little trick I did is just take some packing styrofoam, if you will, cut a couple strips out, then sandwich it in there to give it a nice, cushion, if you will, and fix the problem. Once I put this all back together, it's nice and quiet, doesn't have anything rattling around in it, and that's what we want. What you can see here, when you put that cover on, you'll see there's a little tab on the top. I lead in with that, then slide it to the back, making sure no wires are pinched, and then give it a good visual around the seam line there and see. Why don't we go ahead and try and turn this thing on and see what happens. Woohoo! Look at that. We got power. All right. I think the best thing to do right now is just go ahead and clean this thing up, put it back together, and get it ready to actually do some voltage or resistance testing and get a really good feel for it. So this find is looking really, really good. I think I might just save myself about 400 bucks. It can always be a little scary doing the cleanup on these because you're worried if you're going to actually rub off numbers or emblems or something. And so I just use some mild, warm, soapy water with Dawn grease cutting dish soap in there. And then you'll see some isopropyl alcohol in the background. I'll use that as well if there's some really heavy like adhesive or whatnot. But I really try to stay away from any like painted icons or emblems that I'm afraid I'm going to take some off. I always just try with the soapy water mix first, and then the warmer you can get it, the better. Even the bristle pad that I'm using there is a used, kind of wore out one, if you will, but turns to work pretty well in most cases and does a good job. So you'll see the finished product. All right, back to assembly. When you put these screws in, they are what I call a wood type screw, where it's a really coarse thread going into plastic. You don't know how many times this has been apart. You really want to be careful to make sure that you're not going to crank that in and strip that. So you really get it down there till it kisses, a little bit of ugga, and that's it. These things are not welded in there. You're just going to cause yourself a world of trouble. Well, let's do some final cleanup, snap it in its protective case, and let's do a resistance and a voltage check to really feel good about this. But boy, this thing turned out nice, huh? What a deal. $500 meter. Start to add in tax and get it for 50 bucks. That was a good find, noticing that in that box. I'm going to try the ohm setting. We'll go ahead and plug in our leads, and what we'll do is just test the leads themselves and then make sure that it breaks for OL, for out of limits, or open line, and see what kind of resistance. Now, not knowing how old these leads are, they look physically good. Those are typical resistance, 2/10 there on a set of leads. Let's do a little volt check on a battery. You can see the decimal point is way over on this thing. Let's get a better connection there. Okay, I knew that battery was low. Can run through a range there, and there you go. Get that decimal back to what we normally look at for automotive or power sports applications. My friends, what do you think? I think that thing turned out, and this was quite the find. I really enjoyed this. Cleaning this up, taking a risk. I was able to teach someone else in the shop how to actually do the testing the fuses and inspections. So that's where we grabbed the camera and just had some fun with it. I hope you like this kind of content. If you haven't done so yet, make sure and smash that subscribe button. Please like and share. As always, make it a great day and keep wrenching.